Hello everyone, welcome to DJ की Pathshala Learning Made Easy. Our topic of today is permanent magnet moving coil instrument, which is known as PMMC type instrument. PMMC type instrument usually works on the two basic principles. First one we use is a diastolic movement, that how the pointer will deflect, and second one is the Fleming's left hand rule to know the direction of current. So diastolic movement says that when a current carrying conductor, right, when we have a current carrying conductor, here you can observe that we have a an iron bar. We are supplying a DC over here, and when that current passes through this coil that is wrapped around this iron, it is placed in a magnetic field, right? So north and south poles, here is an horseshoe magnet, and when the current carrying conductor will pass electric current through it, it will generate its own magnetic field and it will collide with the magnetic field that was present with the permanent magnet. Due to this collision, there will be a deflection of the pointer that will be proportional to the supplied current. So this is how the D'Arsnoval principle is used to design the PMMC type of instrument. Left hand rule, I would say that Fleming's left hand rule says that when this current carrying conductor is held in the left hand, and when you keep your thumb field, that is first finger, and the center finger perpendicular to each other, right, on a, I would say, 90-degree, then you can observe that the thrust or the motion, the direction of the thrust or the motion could be identified with the help of the direction of thumb. First finger will identify or will help you identify the direction of the magnetic field that is present in the system, and the center finger will help you find the direction of the current. So with the help of these two principles, or D'Arsnoval movement as well as Fleming's left hand rule, the PMMC or permanent magnet moving coil type instrument is designed. Here is a GIF that is showing that we have a horseshoe magnet that I have already discussed, which is having north pole and south pole. We have a dial, or I would say a scale on which the current will be measured. We have a pointer that is attached with the help of a moving coil. So I have already mentioned that there is a moving coil and the supply is passed through that moving coil. The mirror is kept behind this so that you can avoid the deflection or the parallax or the human sort of errors while taking the readings, and a spring is attached so that the counter force could be balanced as well as the pointer could move freely on the scale. So the working says that when an electric current passes through the coil, right? So when we pass that electric current through the coil that we are supposed to measure, it will generate a magnetic field, and it will interact with the permanent magnetic field that was developed by the horseshoe magnet. And because of this two magnetic field colliding with each other, the coil will start to rotate. And this rotation of the coil is proportional to the supply of the current that is measured over here, and that will be deflected directly on the scale through the pointer. So when the direct current passes through the coil, it experiences a magnetic field, and this creates a deflecting torque. As I have said that it will deflect, it will create a deflecting torque due to the collision of the two magnetic field. And as the coil pointer is deflected, the spring will help to provide a controlling torque, as the torque deflecting torque have started to move the pointer. The spring that is attached over here will help to provide a controlling torque to the pointer, and this pointer then comes to rest position so that the measured quantity could be observed. So we need a stable position to take the reading. So the spring will help to balance the deflecting torque by providing a controlling torque, and we will take the reading through the deflection on the scale. That will be directly proportional to the amount of electric current that is passed over here. As the magnet is permanent and the coil is moving, this instrument is known as permanent magnet moving coil type instrument. So I hope you got the topic. So learn today, lead tomorrow. See you in the next video.